Hello students, chapter number 12 electricity, and presently we are doing the summary and highlights of this chapter of standard 10 subject science. Now Michael Faraday, he is considered as a father of electricity. He was roaming with magnets in his pocket for 17 years and then he invented electrical generator, by virtue of which we are getting electrical energy today, right? And this energy also bites us if we wrongly play with it. Electrical items, lamps, tubes, fans, mobiles, etc. Already I have said that भिड़े के ज़माने का phone और आप लोगों के smart ज़माने का smartphone in which you are watching my videos. Now let us understand two types of electricity are there, AC and DC. As you know, electricity plays very important role in your life, but there are two types of electricity. One is AC, which is alternating in nature, means positive, negative. It keeps on becoming positive, negative. So actually electron vibrates. It does not travel. Whereas in case of the DC, electrons used to drift, electron used to travel, right? So DC comes from the DC batteries. There are different types of the batteries and different sizes of batteries available in the market. Whereas AC we are getting from the power stations. It may be wind power, it may be thermal power, it may be hydro power stations, it may be nuclear power stations and whatnot. So this is the example of thermal power station or nuclear power station. Electricity then travels through transmission lines, and through this type of the poles it reaches to our homes, and these are the electrical meters which charges whatsoever amount of electricity which we have consumed, which we have used. Presently across the India, mostly 6 rupees per unit is the charge. Now what is electricity or electric current? Actually electric current is a flow of electrons. Electrons were first discovered by J.J. Thomson, and then thereafter we came to know that protons and neutrons are in the nucleus. Protons are positive charges and electrons are the negative charge, and neutron does not possess any charge. So valence electrons, the electrons in the final orbit, most external, most valence orbit, most far orbit takes part in the electric flow of the current. They are actually flowing. Electrons, they are loosely bound with the nucleus and they take part in the electric current. So what is electric current? Electric current is nothing but a flow of electrons. More precise definition may be given as a rate of flow of electrons in any conductor, and the SI unit of electric current is ampere. If a net charge Q flows across any cross section, this is the cross section and this is the length, this is the cross section area. If net charge Q flows across any cross section of a conductor in time t, then the current I through the cross section may be given mathematically as I is equal to Q divided by T. And what is the charge of one electron? It is minus 1.6 into 10 raised to minus 19 coulomb, and that of the charge of proton is plus 1.6 into 10 raised to minus 19 coulomb. Now what about the direction of electric current? Most people used to confuse about this, whether it is positive negative or negative to positive. But as we have already studied, as we already told in our detailed lectures, that mostly direction of current is expressed in two ways: conventional direction and the electronic direction. In conventional direction, which is the convention to represent the electric direction, is positive to negative. But when J.J. Thomson found that it's the electron which takes part in the flow of electricity, it was too late. So people started to believe that let us understand it as electronic direction. Let us understand in mind that actually electrons flows from negative to positive, and let us write in books, let us continue to write in books that the direction of current is from positive to negative. So it is a convention. You will have to write in exam if it is asked that what is the direction of current, you will have to write the direction of current is from positive to negative. But in mind you will have to remember that electricity is a flow of electrons, and electrons travels from negative to positive. But chali aati hai to chali aati hai, and we will have to follow this chali aati hai. Now what is the speed of electric current? Actually it is as good as equivalent to that of the speed of the light, that is 3 into 10 raised to 8 meter per second, means 3 लाख किलोमीटर प्रति सेकंड की झड़प से इलेक्ट्रॉन भी इतनी गति से चलता है. But actually it's not the speed of individual electron. Individual electron travels just like this Rangti Chitia, right? This just moving ants, they are traveling at very slow, and it is known as the drift velocity of individual electron. But the effect of electricity. If there is a 6 lakh kilometer long wire, then it will take 2 seconds, because 3 lakh kilometer per second is the speed of the effect of electricity. It is the time required to reach the effect to glow the lamp, that is known as electronic velocity or effect. And drift velocity means the individual speed of individual electron. So basically you are generally told that the speed of electricity is 3 lakh kilometer. Actually it's the speed of the effect of electricity. Electric circuit, it is a path on which electrons flow, right? So in this case you can see that when a switch closes, electrons starts to flow from battery, it lights up the lamp, then again reaches to battery. So electric circuit is nothing but a closed path in which electrons is to flow. These are the different elements: switch, fuse, it is a protective device which should be definitely used. MCB means miniature circuit breaker. Wires, they are the conductors on which electrons used to flow. Now let us consider the potential and potential difference. Actually potential difference is the difference of potence. Potence means some sort of ताकत, एक प्रकार की एनर्जी. जिसके पास ज्यादा एनर्जी उसका हम कहेंगे कि he is having higher potential, right? So actually we may take water as analogous body to understand the potential difference. So some tank is at higher potential and one tank is at the lower potential. Then water will be able to flow from higher potential to lower potential. We may say that the potential energy of this water is higher and potential energy of water at this level is lower. So potential energy of this water tank will be converted into kinetic energy and water will start flowing. So potential energy converts to kinetic energy and water will start flowing from higher tank to lower. So we may say there is a difference of potential. So this is nothing but the difference of potential or potential difference. So technically we may say potential difference is nothing but the difference between the 2 points in an electrical circuit carrying some currents is the work required to be done to move a unit charge from one point to other. So mathematically we may write V, that is V means volt, potential difference, is equal to work W divided by Q, that is V is equal to W by Q, and the SI unit of electrical potential difference is volt or voltage. Now how to define 1 volt? When 1 joule of work is done to move a charge of 1 coulomb from one point to another, we may say 1 volt. 1 coulomb from one point to another by 1 joule of work, then that is 1 volt. Repeat, when a 1 joule of work is required to be done to move a charge of 1 coulomb from one point to another, then this is known as 1 joule. Now let us discuss the symbols. This is the symbol of cell. Bigger side is positive, smaller side is negative. Electrons flows from negative side. Remember, you will have to remember this. So positive side, big size, negative, small side. Battery is a combination of cells, positive, negative, and so on. You will have to connect the negative terminal of a battery with the positive of ongoing battery and so on. Minimum 2 cells are required to form a battery. Higher amount, it may be anything like that. Greater the amount of the cells, number of the cells, larger will be the size of the battery. Open and close switch. When the switch is open, current will not be able to flow. When switch is closed, circuit will be in turn on mode. Circuit is मतलब कि operating है, चालू है. Electrical symbol of joint, crossing, but they are not physically. They may be physically connected. They may be physically attached to each other, but they are not electrically connected. Means current of one line will not be passing through another. Simply they are overlapping over each other. Electric bulb. There may be different types of the electric symbols of the bulb. You may write anyone. Resistor. It is some sort of bump on the highway so that the speed of the vehicle reduces, right? Voltmeter is a device to measure voltage. Ammeter, it is a device to measure current. Voltage measuring device, that is voltmeter, it is always connected in parallel, whereas current measuring device, that is ammeter, is always connected in series. You will have to remember this. Now what is circuit diagram? It is a pictorial graphical representation of electrical circuit mentioning various electrical items like wire, switch, lamps, resistor, etc. so that person can easily understand what the circuit is. For example, in this circuit we do have battery, switch and lamp. All these are connected in series. When we turn on the switch, current will start flow from battery to switch and then lamp to then back to battery. So this is the pictorial representation and this is known as circuit diagram. Now let us discuss Ohm's law. Ohm's law states that the voltage across the conductor is directly proportional to the current passing through it, provided the physical conditions remains the same. For example, temperature means higher the amount of current, higher the amount of voltage dropping across it. Lower the amount of current, lower will be the voltage drop across it. So mathematically we may say V is directly proportional to I, means the ratio of V divided by I, ratio of V and I is always constant. Then this constant term may be represented as R. So V is equal to I, R is the famous Ohm's law equation. And graphically, if we plot the values of voltage and current, this will be some sort of graphical representation. Now what is R? That is resistance. Resistance R is nothing but opposition to flow of current. It's constant for a given material. For example, it will be always constant for 1 meter of say iron and 1 meter of iron. If they are in same dimension, there will be same resistance. But the resistance of 1 meter of iron and 1 meter of say aluminum will be different. So it differs from material to material and its unit is ohm and symbol is ohm, just like the bump, so that the vehicle which is traveling on the road slows down. So the symbol is ohm, which is like bump. Material having very low resistance are good conductors. They are having like super highways. Aaja bhaiya, jaldi se pasar ho ja, jaldi se pass on ho ja. And materials which are having very high resistance are insulators. They will not allow the flow of electrons. रस्सी जल जाएगी पर बल नहीं जाएगा, वो जल जाएगा, मैं इलेक्ट्रॉन को पसार नहीं होने दूंगा, मैं अपने में से इलेक्ट्रॉन को पास नहीं होने दूंगा. They are insulators. Actually, in technical words, electrons are tightly bounded with the nucleus in case of the insulators, and in case of the conductors, for example copper, they are loosely bound with the nucleus. So electrons are free to roam and hence they conduct electricity easily in case of the conductors, where they do not easily conduct in case of the semiconductor, but they do not conduct at all under any conditions are insulators. Now what are the factors affecting the resistance of any item? As we say, longer the pipe, there will be longer the resistance for passing of water, right? So same way, electricity may be represented with water analogy, directly proportional to length. So greater the length of the wire, greater will be the resistance offered to flow of current, and it is inversely proportional to the cross section area of the conductor. For example, greater the size of the this pipe, larger amount of water will be able to flow through it, and if there is some smaller size of the pipe, there will be lesser amount of current will be passing through it, or what lesser amount of water will be passing through it. So greater the amount of cross sectional area, greater the size of the wire, greater the size of the pipe, higher the amount of water or current will be passing. Smaller the cross sectional area, smaller the size or diameter of the conductor or pipe, lesser amount of water or current will be passing through it. In another word, we may say that resistance is directly proportional to length but inversely proportional to area, because greater the area, there will be lower resistance. Water or current will be very easily able to pass through it. To summarize, we may say resistance is directly proportional to length and inversely proportional to cross-sectional area. So, to remove the proportionality, we may say R is equal to rho L by A. Now, a new word, rho. Now, what does the rho stand for? Actually, rho is used to denote the resistivity of a material. It is constant for a material, but it varies with material to material. Alloys, which is a mixture of different metals, generally have higher resistivity. So they are widely used in heater, iron, etc. For example, alloy of nichrome, alloy nichrome, that is nickel, chromium, manganese, etc. It is widely used in heater, iron, etc. Whereas the metals like copper, aluminium, they are having lower resistivity. So they are widely used as the conductors. Copper is generally used for wiring our houses, whereas aluminum is generally used as a transmission line in our transmission towers and for transmitting of electrical power. Which metal is used as the filament of a lamp? It's the tungsten, W. W is derived from the Wolfram, a German word, right? So tungsten, W is used as a filament of lamp, since it is having little higher resistance and higher melting point. So it is used because it is having higher resistivity. Now this represents three conductors, silver, copper and aluminum, you can see that very low resistivity. Resistivity is expressed in ohm meter. You should definitely write the units. So silver, copper and aluminum, it is having very low resistivity, whereas see the resistivity of alloy nichrome. It is an alloy of nickel, chromium, manganese and ferrous. It is having resistivity of 100 into 10 raised to minus 6 ohm meter. So it is widely used in heater, geysers, etc. But now see the resistivity of insulator rubber. It is 1 into 10 raised to 15. So it is having very high resistivity and it will not allow flow of current under any circumstances. Now let us discuss the resistances in series and parallel. First, resistance in series. It is very clear that voltage drop across the difference resistance will be the total voltage of supply. That is V is equal to V1 plus V2 plus V3. And according to Ohm's law, we may say that V is equal to IR. Hence, for same voltage drop also it will be applicable that V1, V2 and V3 will be simply IR1, IR2 and IR3 respectively. So to summarize, we may say that IR is equal to IR1 plus IR2 plus IR3. It gets I cancel from both sides and finally we will be get that series resistance R, net resistance R is always equal to the sum of resistance connected it in series. For example, R is equal to R1, R2, R3 etc. and so on. It's sum, right? So R is equal to R1 plus R2 plus R3. Now in case of parallel corrections, we do know that current divides total current is I, that is V by R, is equal to I1 plus I2 and I3. So according to Ohm's law, I is equal to V by R, total voltage divided by total current. Same thing is applicable to I1, I2 and I3, that is V upon R1, V upon R3, R2 and V upon R3. So to summarize, we may say I is equal to I1 plus I2 plus I3. Applying Ohm's law, V upon R is equal to V upon R1, V upon R2 plus V upon R3. So solving this, we may say that total equivalent resistance, if it is R equivalent, then 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on if there are number of resistance connected in parallel. So in series, simply it's the sum of arithmetic sum of resistance, whereas in case of the parallel, you will have to inverse every item and you will get the answer in inverse again. Now what are the heating effects of electric current? We do know that power is equal to voltage into current. It is a product of voltage into current. So heat energy is power into time. Any energy is nothing but the product of power and time. So applying these two equations in a common way, we may write heat energy H is equal to VIT. Now applying Ohm's law and replacing V with IR, we will get heat is equal to I square RT. In practicality, heat actually leads to loss. Heat actually leads to efficiency downgrading, right? But in practical, there are many applications of this heat loss too. For example, no doubt it is undesirable in most cases, but it may be useful. आपदा को कैसे अवसर में मानो कि पलटे. For example, heat is to be used in geyser, electric iron, etc. Right? So there are many practical applications of electrical heating. Even in furnace, they are using electrical heating. Tungsten is used, which is having higher melting point, almost as good as filament tungsten. The current will be passing through this filament and that filament will just having higher resistivity, higher resistance. So heat will be produced, I square RT, heat will be produced in that tungsten and it starts glowing, and that glowing effect we do observe for lighting. For example, you are burning the wood, it gives heat, but also as a side product it gives light energy also, right? Same thing is applicable in this lamp, but actually it is inefficient because actually we need light energy, but actually it is burning. Burning means it is giving heating, and as a side product it gives light energy. So now advanced form of the light sources like LED and CFL have come into market. Now what is a fuse? It is a simple yet powerful protective device containing a special wire which melts and breaks the circuit if current exceeds desired safe level. Repeat, this is very important from the examination point of view, that it is a very simple and protective device containing a special wire which melts and breaks the circuit if current exceeds the desired level. So that safety first slogan may be observed. Actually, fuse consists of two parts, base and a upper layer called the fuse. Now this upper layer or fuse, which is primarily known as fuse carrier, is consisting of two contacts and a wire. This wire will burn away if excess amount of current will pass through it. Why? Because it is consisting of a special wire which is having higher resistance and lower melting point. So for example, if 2 ampere of current will be flowing, 2 will lead to I square RT means 4 RT. But if it is 3 ampere of current flowing, then 3 square RT means 9 RT. You can now see the difference from 2 ampere to 3 ampere, from 4 to 9. Simply difference of 1 ampere current leads to difference of 4 to 9. Almost double or triple, and the effect will go on cumulatively increase in higher amount of the current. So what I mean to say is that slightly increase in current will lead to very drastic amount of heat increase. So it will have very high amount of heat generation for the small change in current. So if the current exceeds the desired safe level, it immediately breaks down, melts down. Now this is a fuse material, fuse wire material. Actually it is an alloy of tin and lead. Tin is represented as SN, which stands for Stenon, SN, and lead, that is PB. PB stands for plum. Both are Latin words. So fuse wire is nothing but it is a combination of tin, that is Stenon, and lead, that is plum. It does have high resistance. At the same time, it is having very low resistance, low melting point, nearly 200. Now what is electrical power? It is a rate of doing work, that is known as power. And electrical power is rate at which electrical energy is used, dissipated or consumed in the electrical circuit, and its SI unit is W, that is watt, in the memory of James Watt. Power may be expressed as VI, or product of voltage into current, and if we use Ohm's law, then it may be expressed as either I square R or V square by R. Energy, it is nothing but the product of power into time. So we may say that energy is equal to power into time, or power may be VI into time if power is known as power is known as VI. So even in just like a previous case of the heat, we had said that energy or heat energy is equivalent to power into time, that is VIT, and it is expressed in joule. But since joule is a very small amount of energy, so commercially kilowatt hour is used. And now what is 1 kilowatt? Kilo means 1000. So 1 kilowatt hour is equal to 1000 watt into 3600 second, which stands for 1 hour. So mathematically, if we reduce the expression, we will get 1 kilowatt hour is equal to 3.63 into 10 raised to 6 joule. And this is the commercial unit which is used worldwide to measure the amount of electrical power used, including in our homes, right? So this was all about electricity, chapter number 12. Thank you. For more such videos, simply search YouTube Free Education by RK. If you are having any questions, doubt, you may write in comment. I will try my best to answer the question as soon as possible. Thank you.